Hello everybody, my name is Ajit Abraham and I am here to share a bit about FoxPro JavaScript and Node.js. After my formal education in India, I got an opportunity to come to this beautiful island in the Middle East, the Kingdom of Bahrain. I joined RCal almost 3 decades back and I am blessed to be surrounded by owners and colleagues who value a well-balanced life. Today's agenda would be to have a brief look at the FoxPro call stack, introduction to JavaScript, a bit about Node.js, and finally, we will explore the possibility of accessing our Fox data and Fox reports through a web client through Node.js. My session has few slides and more of heavily edited screen recordings with the help of Camtasia. I did this so that I could cover maximum material in the given time slot. Let's start with some basics on FoxPro. During this session, I will make an attempt to explain concepts like call stack, synchronous and asynchronous code, blocking and unblocking code, event loops, threads, processes, etc., etc. But I have oversimplified it, taking a risk. An experienced developer might be thinking, hey Ajit, there is more to it. I know. But I feel this should be enough for a newbie to get started, and then he or she can research more about it on the web. All FoxPro developers have seen this call stack window in the debugger. So what's a call stack? It shows the current active code of a running program. Let's take a simple program which has 3 lines of code. Let me represent a call stack with this rectangular window. When you run the first.prg, it is loaded into the call stack. The first line is executed from the call stack, which displays the hi window. When we press a key or on a mouse click, that code is taken away from the call stack and the program continues to the next line and loads up the first function. The first line of the first function is executed, which displays the window. On a user interaction, the window disappears and that code is taken away from call stack. There is no more code in first function, so it is taken off the call stack. The third line of the program is executed from the call stack, which displays the last window. On a key press, this window too disappears and code is removed from the call stack. No more code, so first.prg is removed from the call stack. Okay, so what happens in an event-based program? Here the flow of program is determined by events, like a button click or a page load event or a timer event. As you can see, I'm using the 32-bit version of Visual FoxPro Advanced developed by Chen. To know more about Visual FoxPro Advanced, please watch Dr. Ryan's session. I created a blank new form and in the load event, I put a wait window message. I put a button on the form. I changed the caption and I put a code in the button click event. I ran the form, the load event is fired, I click the button in the click event is fired, and I close the form. Now let's see this in our call stack slide. When we issue a doForm command in the command prompt, there is an implied read events which activates the event loop. By the way, if we had issued a doForm in a PRG, for example, then we had to give a command read events. All events will be placed in a queue. Let's call it event queue. The first event to occur in our example is the load event. The code of the load event will be placed in the event queue. As our event loop is running, the load event code will be put in the call stack. As there is code in the call stack, the event loop is blocked. The wait window is shown. Until all the lines of the load event code is not executed, the event loop will remain blocked. When we press a key, the wait window goes. As there are no more lines in the load event code, the call stack is empty and our event loop runs again. When the button is clicked, the code in the click event is put in the event queue. As the event loop is running, the button click code will be put in the call stack. The event loop is now blocked and will remain blocked till all the lines in the button event code is executed. This means that even if there are other events raised, like our timer event code, it will get placed in the event queue, but we'll have to wait for the event loop to be free. The wait window is shown, and when I press a key, the wait window goes, and as there is no more code in the button, the event loop starts again. So in short, events can happen, and as and when they happen, the code of those events are placed in a queue. The code gets transferred to the call stack only when the event loop is running. And when does an event loop run? When the call stack is empty. Next, a small introduction to JavaScript. Communication on the web is usually between two computers, a server and a client. So a client requests data and the server sends data, and most of the time the client is a browser. In early 1990s, a company called Netscape dominated the browser market with its Netscape Navigator. Those browsers were limited to displaying text with limited styles and images. But when other software giants started competing in the browser market, Netscape called upon Brendan Eich to make the browser more dynamic or more interactive. And Brendan did build a prototype in just 10 days. This prototype eventually became JavaScript. Here is Brendan.
22 years ago, in May, I did 10 days of hard work. I didn't sleep much.
JavaScript was not a popular language initially, but it withstood assaults from VBScript, ActionScript, Silverlight, Dart, TypeScript. So JavaScript, I think, will be the browser's default scripting language, at least for the near future. So how does a browser execute JavaScript code? Browsers come bundled with a JavaScript engine, which takes the code written between the script tags in an HTML document and converts it into machine language. Each browser vendor has their own flavor of JavaScript engine. Chrome has V8, Safari has JavaScript core, and this also explains as to why sometimes some sites come with a warning that their site works best in Chrome or works best in Edge. JavaScript and FoxPro both execute their code line by line. That is, their code are executed synchronously. But a FoxPro program can run independently in Windows. It just needs its runtime DLL files. JavaScript too can run only if a JavaScript engine is present, but it can never run independently in an OS. It can run only in an environment like a browser. Now, why this is special? A browser can display text with styles, it can execute JavaScript code, and it also has web API functions that are asynchronous in nature. And you know what? JavaScript can execute these browser APIs asynchronously. So how are these web APIs executed? There are two parts to it. First, the web API takes in an optional parameter for it to function properly. And the second one is, once it's done its job, it kind of announces that I have completed my job. So JavaScript will execute a special code known as a callback code. We will quickly see an example of this. So let's create a new HTML file in Explorer, call it test.html, open up it in Notepad, and between two HTML tags and between two script tags, we'll have three alert functions. Alert is equivalent to wait window of FoxPro. So I'll have three alerts. I love FoxPro. I'll save it, open up in our favorite browser. So I'll get I love FoxPro. Now let's introduce the concept of variables. We'll replace the word text string FoxPro with a variable language equal to FoxPro. It's a string variable, and I will alert the language. Save the file. Once again, open up in our browser. We should get exactly the same thing. I love FoxPro. Now let's introduce the concept of JavaScript objects. A JavaScript object is always written between curly brackets. A JavaScript object is a collection of property names and values. So let's say I have three properties, two string and one number type, short name, long name, and word. And now let's alert the long name, language.long name. Let's save it, run it. We should get exactly the same now. I love Microsoft Visual FoxPro. Now a word regarding JavaScript property names. Property names need not have a quote around it. It's totally optional. But the reason why I always put in all my codes is because if the property name happens to be a JavaScript reserved word, then it's compulsory for us to put quotes around it. So I don't take any chances. I just put quotes in all JavaScript property names. Now, a JavaScript object needs to be sent back to the server, and we need to get a JavaScript object from the server to the browser. Sometimes we need to send this JavaScript object to FoxPro, for example, as we'll see later on. It can't be sent like that. It can't be sent as a JavaScript object. We have to convert the JavaScript object into YAML or JSON or XML. We will use JSON in our example. And if you see the difference between a JavaScript object and a JSON object, the only difference between them is the single quote around the JavaScript object. JSON data is a collection of key and value pairs. A JSON key should have quotes around it. It's compulsory. So if I make a policy that all my JavaScript object property names will have quotes around it, then the only difference between a JavaScript object and a JSON object is the single quotes around the JSON object. So what we are doing is we are actually converting a JavaScript object into a text type. We are stringifying it. And a JSON object we are converting into a JavaScript object by removing the quotes or by parsing it. Okay, so now let's get our JavaScript object from a remote server. There are many places where we can store our data, dummy data. One of them is mocky.io. So let's create a new mock, and in the response body, I will go back to my notepad. I will copy the JavaScript object and paste it into the response body. I'll generate a new URL, a mock URL. If I click on the mock URL and if I open in another tab, I should be able to see the JavaScript object. Next, let's remove our local JavaScript object. Now, how to get the remote data? Well, JavaScript does not have any inbuilt functions to get remote data. But our browser, as we have seen in the slide, has certain web APIs. And one such web API, an asynchronous web API, is called the fetch function that takes in a parameter, which is our mock.io URL. And we will also write the callback code, which will be executed once the data is fetched. So the alert function here is our callback code. Save the file. Open the file in a browser. I love FoxPro. Hooray! The fetch function got the data from our remote mocky.io and was shown by the alert in our callback code. So let's do one thing. Let's put the fetch function as the second command. So it should say I FoxPro love. Save the file. Open up in browser again. So I should see I FoxPro what? Love. And then FoxPro. It should have displayed I FoxPro love. What happened? Okay, let's do one more thing. Let's move the fetch as the very first command before all the alerts. And just to make sure the cache is not playing anything, I changed my second alert. Save it. Open a browser again. And the second alert is getting executed first. I really love and my fetch command is always the last. It should have displayed FoxPro I really love. Let's see the execution of our code with the fetch API as the second line with the help of our call stack diagram. I once again apologize for the oversimplified diagram. Okay, this is our call stack. This is a queue. Let's call it as the message queue. Then we have the browser APIs. This is our event loop. And as soon as the JavaScript is loaded, all 3 lines of code get into our call stack, which blocks our event loop. The first alert is executed. It is shown. I click on OK. Message disappears. Alert is taken off the call stack. The next fetch is now handed over to the web API along with its callback. What is left now in the call stack? Alert love. And that's what gets executed. Now let's assume we have not yet clicked on the OK button of our alert love. And during this time, the fetch function got our JavaScript object from the remote server. Hence, the callback was placed into the message queue. I click on OK of love, that goes. Alert love is taken off the call stack. There's nothing in call stack, so my event loop is free. So the alert FoxPro is now put into the call stack from the message queue. Call stack gets blocked. Alert is shown, alert FoxPro. I click on OK. Alert is taken off the call stack and my event loop is free. Now you see why we get the alert I love FoxPro instead of I FoxPro love. I hope you get some idea of the way asynchronous events are executed. In case you're wondering why we had to use 2 thens in the fetch command, whenever we fetch an URL, the stream comes in 2 parts. First comes the header and then the body. Our JSON data or the word FoxPro lies in the body, which is captured in the second then. This asynchronous behavior of JavaScript got one person got very excited. Californian Ryan Dahl. He was in the quest of building a fast web server as he was not happy with the usage of threads by existing web server at that time. Let's briefly look at threads. Earlier PCs had a single core. Single core means the processor can execute one instruction at a time. It can execute instructions at amazing speeds, but it can execute only one instruction at a time. We can imagine the instructions coming in a pathway to the processor. In Windows Explorer, if you look at any executable, as long as the file is on disk, it is dormant. As soon as you start it, it becomes a process, which you can see in the Windows Task Manager. So the dormant file has now become a process. So in our example, FoxPro has become a process and will open a pathway to communicate with the pathway of the processor. So now the processor can execute instructions coming from a FoxPro program. But FoxPro is not the only process. There are hundreds of processes running on a PC, and each process has a pathway to communicate with the processor's pathway. This pathways is actually threads, software threads and hardware threads. So how does a single hardware thread able to deal with so many software threads? One of the ways is through time slicing. So in our example here, the time scheduler will give a few milliseconds to Excel to do its stuff. So for Word, so for FoxPro. The processor executes instructions so fast, we think that all processes are running at the same time. Today's CPU have multi-core processors. So in case of a quad-core processor, there are 4 hardware threads. So the PC can perform 4 instructions at the same time. And if the processor and BIOS of your PC support hyper-threading, it can make Windows believe that the PC has double the actual number of cores. So in our example of a quad-core processor, the PC can execute 8 instructions at the same time, resulting in a very happy user. In the above example of processes, I assumed that each process has generated one pathway or one software thread, but that's not the case. The developer of the program can launch multiple pathways, or also known as worker threads, to execute multiple instructions at the same time. For example, Word. That's how Word can check for spellings while you type. If you download a program like Process Hacker, you can see the processes as you have seen in the Windows Task Manager, but now you can see how many threads or pathways each process is using. Word has launched 12. Interestingly, FoxPro has launched 8. Unfortunately for Fox developers, we have access to only the main thread. All our FoxPro code gets executed in the main thread. A process can have multiple threads as we have seen before, but a process can also launch itself again as a child. Look at the Chrome browser process. Whenever we open a new tab in Chrome, instead of a new thread, Chrome launches another child process of itself. So this is just another way of making the user experience smooth. By the way, as a side note, multi-threading can be achieved in FoxPro too. Look at the presentation given by Kevin in a Southwest Fox conference a few years back, and also have a look at Joel's Parallel Fox. So why was Ryan unhappy with those old web servers? Those web servers used a new thread for each incoming request. Ryan argued that incoming requests can be handled by one main thread, and it can hand over any IO or database requests to other threads or child processes. So he created Node.js, which can execute JavaScript code. Just like Chrome, he used V8 as the JavaScript engine. Node can work on Mac, Linux, and Windows. The way Node.js works is quite intricate and beautiful. I am trying to show an oversimplified version of it. Please don't crucify me. There is a call stack which has the current code. There is some kind of queue. Instead of web APIs, we have the Node APIs, and this is our event loop. Remember, whatever JavaScript code is in our call stack will always be executed on the main single thread. Let's say we get our first incoming request. As the call stack is empty, the code for the first request is put in the call stack. And let's say that there is two parts to the first incoming request. First is to validate the user, and second is to get records from a Mongo database. The code to validate in our case will be executed on the main thread. The user has been validated. So the second code to access the records from MongoDB will be handed over to the Node APIs. Event loop starts again as the call stack is empty. The MongoDB processing will happen on another thread. In the meantime, I get some more requests. Those requests will be loaded in the call stack, blocking the event code. So let's assume that the MongoDB response is prepared. It will now be put in the queue, which is our first outgoing response, which will eventually be put in the call stack as in when the event loop is free, and then the response will be sent back to the user. So as Node developers, it's our responsibility that we never write blocking code in the main thread. Philip Robert has given a very good explanation at a JS conference. Here's an audio clip.
The event loop, this is exactly what they're talking about. They're saying don't put shitty slow code on the stack, because when you do that, the browser can't do what it needs to do, which is like create a nice fluid UI.
Let's start with Node, with the Node installation. Visit nodejs.org. Click on the button on the left, which will download the stable version, and install it. Accept all defaults except for one. Click on Next, and in the tools for native modules, you have to select this and then click on Next. I'll explain later on why this is necessary. And go on with the normal installation. Click on Finish, which completes the main Node.js installation, and now it will proceed to download and install the native tools. Installation is complete. Now go to DOS prompt and type node -v, which should display the node version number. Type node and press enter. You will be in the node environment, and you can type here any JavaScript code. To come out of the node environment, press Ctrl+C 2 times. Let's see the development environment of Node as compared to FoxPro. In FoxPro, files are organized in a project manager. In Node, we use Windows File Manager. In FoxPro, commands are given in a command window, while in Node.js, we use the DOS prompt. FoxPro has inbuilt editor for all its files. For Node.js, we have to use a JavaScript or an HTML editor. So for Node.js, we can switch between the editor, the DOS prompt, and the Windows File Manager to get our work done, but it will be very inconvenient. Fortunately, there are many tools available which combines all three. One of them is the free Microsoft Visual Studio Code. Download and install it. It's very simple. Next, let's do a new project in Node. Open up command prompt, make a new directory. Let's call it FoxWest. cd into FoxWest and type code space dot. This will open up Visual Studio Code. On the left, you can see something like a Windows File Explorer. On the right side is the editor. The command prompt is missing. So go to Terminal, in the menu, New Terminal, and there you have your command prompt. If you're using Windows 10, this will be actually the PowerShell, which is an advanced version of command prompt. Okay, so now let's create a new JavaScript file. Right click on the Explorer tab, select New File, give a name utility.js, and we'll create a function to determine if a given number is prime or not. So let's call that function as isPrime. It will take in a parameter. Let's call that parameter as number. We'll initialize a variable answer with a Boolean value true. A for loop to check for the primeness of the number. And finally return back a JavaScript object with two properties, the number itself and the result. We can write better logic to check for primes, but for our simple example, this should be fine. Now let's create another JavaScript file and name it server.js. Our intention is to call the prime function of utility.js from the server.js file. In FoxPro, we would have done a set procedure too, and then call the isPrime function. In JavaScript, we will use its require command, which will load the utility.js. The file name should be preceded by its relative path and should be written in quotes. The file should be loaded into a variable of our choice. The extension JS is optional. By the way, a JavaScript file is called a module. Our utility.js has now been loaded into a variable called ut. Now, when you type ut followed by a period, the Visual Studio IntelliSense should show our isPrime function. But as you see, it is not. The reason for this is, unlike FoxPro, all functions defined in a JavaScript file are private. So let's go back to our utility.js and make our isPrime function public. This is done by module.exports function. Put our isPrime function within curly brackets. Now when we go back to server.js and type ut followed by a period, we can see the isPrime function. Let's check if 100 is a prime number, and let's store the answer into a variable. To display the answer in our terminal, we will use the console command. From the main menu, select File, Save All. Go to the terminal and type node space server.js and press enter. This will display our JavaScript object in the terminal. Let's change the number 100 to 31069, which is a prime number. Save all and run the command again by pressing the up arrow key and enter. We will get our desired result in the terminal. Before we go further, let's see the different ways variables are declared in JavaScript. One of them is by using the keyword var, var. Another is by using the keyword let, let. We can also use const, const, And we can also declare without using any keyword like we do in FoxPro. The var keyword actually has been replaced by the let keyword, and it removes certain nuances of the keyword var. You can Google for those if you are interested, but I always use the keyword let to declare my variables. Now let's see the scope of let keyword. If the let is declared outside the functions like our place variable, this variable will be available in all our functions. If it is declared within a function, then it will be available only within the curly brackets of that function. And if it is declared in the for loop, then it's available in the curly brackets of the for loop. Similarly, if it is declared within the if, then it's available only within the curly brackets of the if condition. Now the const keyword is exactly same as the let keyword, except for the obvious, which is you cannot change the variable once declared. The scope of const is similar to the scope of let. If you change the const variable and run the program, you will get an error. Okay, we can declare a variable without any keyword, but this will result in the variable being available globally in all our functions, in all our JavaScript files. It's similar to FoxPro's underscore screen dot add property. The equivalent of underscore screen is the global this keyword of JavaScript. But using global this is entirely optional for global variables. This is dangerous and should be avoided. If you need to use global variables in Node.js, then use process.env property. Please Google for more details. So you see, in JavaScript, I use only the let and const to declare variables. Now let's enhance our isPrime function to find the time taken to determine if a number is prime or not. We will declare a variable before the for loop and initialize it with the current date and time. Similarly, we will have another variable after the for loop. We will now add a third property to our JavaScript return object, which is time taken, which will be the difference between the two variables in milliseconds. When we run server.js, we will now get the time too. Now let's add another function to convert the milliseconds to minutes and seconds. The logic is simple, so I'm not going through all the steps. We will replace the time taken property with a call to our new function. Let's change the number to be checked to a bigger prime number. Save the file, run server.js, and it took a couple of seconds to get the answer. Okay, now let's talk about developer community. The success of any platform depends upon the contribution of community members. That's true with FoxPro as well as Node.js. There are tons of free utilities contributed by FoxPro community, and we can download them from many sites. The Node.js community usually upload their utilities or packages as they are called to a site called npmjs.com. There are more than 1 million packages available at this site. Before we see how to download packages from npm, let's touch upon one more topic. In FoxPro, we can fill in information about our project like the author name, etc. by pressing Ctrl J and filling in the information. In Node, we need a file called package.json, which we can create manually and fill certain information, but still better, we will take the help of npm commands. npm commands gets installed automatically when we install node.js. So in our terminal, we type npm space init and press enter. It will ask a series of questions regarding our app, and at the end it will create the package.json file. So package.json is made up of some properties and values. Now let's practice installing one or two packages from npm. Go to npmjs.com and in the search field search for the word countries. There are more than 500 packages as you see having that word. We are actually searching for a package that will list out all the countries of the world. World countries capitals. Let's check it out. This page will show the details of the package as written by its author. On the right it shows the installation command. Let's go back to our server.js file. Select all the existing code and press Ctrl / to comment all of it. Now in our terminal, type in the installation command as shown by the author and press enter. The npm command will now download the package. You will notice three new things. First, our package.json file has a new property called dependencies, which contains our new package and its version number. Second, a new folder called node_modules, which has a subfolder with our new package name. If you expand world countries capitals, you will find its package.json file, which will show its dependence property. So this package is now dependent on another package known as Jasmine Console Reporter. Now this folder too is present in nodes modules folder, and if you open its package.json and check out its dependencies, you will find all of them are in the node modules folder. I think you get the idea. Now the best thing is we never have to fiddle around with the node modules folder and its contents. And lastly, it has created one more file called package lock.json, which we can ignore for our example. Let's start using our new package. First, we need to load it. We will use the same require command that we used to load our local utility.js file. But for packages in our node modules folder, we don't have to put paths before the file name. Let's load it into a myworld variable. If we go back to the npm page, we see that the package exposes a method called getAllCountries. Let's store the result of that into a variable called myCountries. Finally, we will display the result in our terminal. Save the file and run server.js. We will see the countries list in the terminal. Okay, now let's practice with another package called validator, which can validate if a given string is a proper email or not. So let's search for it at the npm site. The install command is shown green. Type the same in the terminal and press enter. If we now check out our package.json file, we will see the new entry in the dependency property. Also, our node modules folder will have the validator folder. Let's go back to server.js and select our previous code. Press Ctrl / to comment it. Load the validator package into a variable called, let's say, validator. Validator has a method called isEmail, which we will use now to check if foo@bar.com is a valid email and print the result in the terminal. Similarly for an invalid email, and we get the corresponding result. So now we know how to install and use a package from npm. Uninstallation of a package is easy to type npm uninstall and the package name. So let's uninstall validator. Done. Now if you check package.json file, the validator entry is removed from the dependency property, the directories from Node modules would be removed too. Similarly, let's uninstall world countries capitals. The dependency property is empty now, and so is the contents of Node modules folder. In fact, the entire Node modules is missing, though I'm not sure that was done by npm or by Visual Studio Code. Anyway, I hope by now you are a bit familiar with npm packages. Fine. Now let's not forget why Ryan created Node. He wanted to build a web server. So let's create one. Node does have inbuilt functions to create a web server. But for this session, we will use a package from npm called Express. 12 million downloads per week. Wow. It seems everybody on the planet is a developer. That's the command to install Express. Let's type that in our terminal. Our dependency property is updated. From the npm page, let's start copying the initial code to server.js. First, we load the module in a variable Express. Next, we initialize Express, which returns all the required methods. Let's store that in a variable called app. Next, app.get. This is an asynchronous command. It informs Node, when you get a hit on the root, that is the IP address of the server, then execute the callback. The callback simply returns a text, hello world, back to the browser. As app.get is an asynchronous command, JavaScript does not pause here. It goes ahead to the next command, which is app.listen, which is another asynchronous command, which informs Node to start listening to requests on the IP of the Node server on port 3000. Save all the files and run server.js. Oops. To check, I have to know what is the IP of my machine so that I can type it in the browser. So press Ctrl C to cancel the app.listen command. Type ipconfig and you see that my laptop IP is 192.168.100.4. Start server.js again, open up browser and type in the IP address with 3000 as the port number. We got the text, hello world. There is our first web server in action. The app.listen is somewhat similar to our read events of FoxPro. It will not allow the Node program to exit, and it will listen to incoming requests or events. App.listen will not allow the Node program to exit, and that's why we had to press Ctrl C to cancel the app.listen. We can also add a callback to app.listen to display some text in the console when Express is ready to listen. Now when you run server.js, Express will display that callback code when app.listen is ready. Press Ctrl C. Just to prove that the app.listen is asynchronous, if we move the app.listen above the app.get, our program will still work. Save the file, run server.js again. It works as before. We have seen the main route. Now let's add two more routes, /foxpro and /node. Make a copy of the root route and change the path to FoxPro and change the return text. Copy once more, change the path to Node and change the return text. So now we have three routes in total, the root route, the FoxPro route and the Node route. Press Ctrl C to stop the server, save the file and run server.js again. In the browser, if we go to the FoxPro route, we get the text written in the callback of the FoxPro route, and for Node route, we get the callback written in the Node route. Now, if we need to have some kind of feedback whenever a route is being hit, then we can simply put a console.log in the callback of that route. So we do that in the FoxPro route, save the file, press Ctrl C, restart the server and hit the FoxPro route. We get the display in the browser as well as see our text in the terminal. Let me check the routes again, but this time I will check on my mobile. I am using an app called Visor, VYSOR, to display my mobile screen on my laptop. And when I open my browser and input my laptop's IP address, the route, the FoxPro route, and the node route all works. Okay, so far we have been running our server.js file by typing node space server.js. The JS extension is actually optional, so we simply type node space server. There is a third way too, this time using the npm command, the npm run command. If you open up our package.json file, you will find a property named scripts, which has two entries, test and start. We will not be using the test, but if you see the property name start, it has the same value we were using before to start our server. So the third way of starting our server is npm run and the batch name, which is start. This is similar to our .bat files in DOS or Windows, which runs our batch files. It works as before. Pressing Ctrl C will now terminate the batch job. If you would have noticed, I have been doing some things quite repeatedly. After making a code change, I save the file, then I go to the terminal, I press Ctrl C to cancel the app.listen and run the JavaScript file again. What if the server is automatically restarted when we save our code changes? Well, this is possible with a package available on npm called Nodemon. As you see, this is quite a popular package. Let's install it. It's installed. Now let's open up package.json file, and under scripts we will add a new property. The property name can be anything, but I'm naming it dev, D-E-V, and the value will be Nodemon space server. Save the file and run this script with the npm run command in our terminal. The server will start. Let's make a small change in the server.js file. Let's write a console command for the node route, just like we did for the FoxPro route. Now, as soon as I press Ctrl S to save the file, our server.js is run again automatically. This saves a lot of developer time. Fine. Now, it's a good practice to move all our routes to a separate file rather than cluttering up the server.js. So let's do that. Create a new file, name it approute.js. We will need our Express package here. Next, we will initialize not the Express but express.router and store it in a variable router. Now copy all the routes from our server.js and paste it into our new file. We need to change the app variable to the router variable. One last thing we need to do is to expose our router variable, as it will be used by server.js. In our server.js, we will load the new file, and as this is a local file, we will need the relative path in the front. Finally, we will use Express's use method to direct all our routes to our new approutes.js file. Save all files and let's check. It's working fine. So we have successfully moved all the routes to another JS file. Next, let's see what is middleware. What if we need to run a special code that should run on all routes? This is known as middleware. Let's say we want to count the number of server hits. We can do so by using the use method of router. Here I have named the function timelog, but it can be anything. In fact, we don't even need to have a name. We will initialize a variable called hits, and in the middleware function we will increment it and even display it in the terminal. Save the file and hit the server. In the terminal we will see our middleware in action. Hit the server again. Oops, I made a mistake. There is no such route. Anyway, hit the server again correctly a third time and we can see our 3 hits including the wrong one. Okay, now let's do something interesting. Remember our isPrime function? What if we want to call our isPrime function from the browser? For this, we need to pass in a value like this. So we want to find out if 12321 is a prime number or not. It's actually very easy. We simply define a new route. Let's make a copy of the existing node route. Change the word node to, let's call it is it prime. Change the text that is to be shown in the terminal. Now, how to capture the passed value 12321 from the browser? Express makes it very simple. Simply add a colon followed by any variable name after the route name. I will call the variable name as number. That's it. Now I can get hold of this variable by accessing the params property of a request object followed by our variable name. If we rename the variable to, let's say, num, we will need to do the same in the params property of our request object. Initially, I want to check if this route is working. So I will just send back a test string. Save the file and run server.js and hit that endpoint through browser. You should see the text in our terminal with the num variable populated correctly. Now, in order to call our isPrime function, we need to load our utility.js file. In our isItPrime route, we will call the isPrime function by passing the populated variable num and store the result. If you recollect, the returned object from our isPrime function is a JavaScript object. This will be stored into our variable ans, which we will send it back to the client, that is our browser. Save the file, server will automatically restart. Hit the server again, and this time we can see the JavaScript object as returned by our isPrime function. I hope you appreciate how easy all this is. Let's try another number, 19991, which is a prime number as seen in the browser. Now let's try with a bigger prime number, 67867967. Hit enter and it's taking time. Let's check out our terminal. Sure enough, our isItPrime route was hit correctly, but our isPrime function is taking time to check. If we go back to the browser, yes, it took 10 seconds for Node to return back the answer, all because of our shitty, slow isPrime logic, creating a very unhappy user. That's not the only damage our slow code has created. Let's prepare a tab with an endpoint for a large prime number and another tab with a much smaller prime number, and rapidly execute the first tab and the second tab. You will notice that the second user has to wait for the first user to finish. Our isPrime function, which is being run in the main JavaScript thread, is blocking incoming requests for the number 13, as it is busy with the calculation of the large number. As you see here, as soon as the first tab is done with, the second tab with number 13 is immediately executed. So in short, our isPrime function contains blocking code, and it is a very bad practice to write such functions in Node.js or JavaScript in general. But what if we are stuck with this kind of code? There is a way out. It's not very efficient, but let's explore it. If you can recollect how Chrome handles this situation, it launches child processes on different threads to make a better user experience. Let's check our node process in our process hacker. Our terminal is here, which is actually the PowerShell.exe. Let's start our script dev and see that in the process hacker. Nodemon 2 has launched Node a couple of times as child processes, so we cannot use Nodemon to learn about child processes. Let's start our server.js normally and look at the process hacker. Yes, this is what I want. Our server.js is running under a single node process. So what is our aim? When we get a hit on isItPrime route, we will run the isPrime method in a different thread by running this method in a child process. This will make our main JavaScript thread free for incoming requests. We need to fork out another instance of node under our main node. This second instance is called a child process or a sub-process. The child process will obviously run on a different thread. We will see how all this works practically. So our parent node process will create a child node process. We will establish communication between the parent and the child processes. And finally, we will end the child process. Let's see the methods available to us for the communication between parent and child processes. If the parent has named the child process as, let's say, CP, then to send data to the child process, we will use the cp.send method. The child process has a listener method which captures the data sent by the parent. This method is known as process.on. Note that the process.on first parameter method is compulsory. If the child wants to send data to the parent process, then the child will use process.send method. And finally, the parent's listener method is cp.on, which captures the data sent by the child. Once again, the parameter method is compulsory. Back in our isItPrime route, let's comment out our call to isPrime function. We do not need to load our utility.js either. We will create a child process when the route is hit. Node.js has an inbuilt module called child_process, which has a fork method. Let's load that to a variable called, let's say, fork. Next, we will now create the child process and name it CP. We will pass our blocking code JavaScript file as a parameter. So the child process will now run with our utility.js file. It's that simple. The above 2 lines of code created a child node process. Remember, we are in the parent process. So the parent process will send the data received from the browser to the child process. We will use the cp.send method and we will pass it as a JavaScript object. The JavaScript object will be just one property name number. We can give it any name we want, but we'll call it number. And the value will be the data captured from the browser. While we are in the parent process, let's also define the listener. So when the child sends data, we can capture that using the cp.on method. We will store that in a variable called, let's say, ans, which will be sent to the browser. Now in utility.js, remember utility.js is now running in the child process. Now here let's write methods to communicate with the parent. First, the listener, which will capture whatever the parent sends. In our case, we will capture this into a JavaScript object variable called JSOBJ. We can give any name we want. In the listener, we will call the isPrime function, which is available below, with the passed number. And the result we will store in a variable called ans. And finally, we send this ans variable to the parent, which is done by the process.send method. That's it. We have completed all the 4 communication methods. We no longer need to expose our isPrime method, so we will comment it out. Save all files, run server.js, and let's check in browser. It's working as before, except for the important change that our blocking code is now running in a child process in a different thread instead of the main JavaScript thread. There was one last step to be done, which was to terminate the child process, which I did not do it purposely, so that we can look at the process hacker where we can see clearly our parent process and the child process in which our utility.js is running. So how to terminate the child process? In the child process, simply type process.exit. That's it. This will terminate the child. Save all files, run server.js. In one tab, prepare the endpoint for a large primary number, and in another one, prepare the endpoint with a small primary number. As you see, the second user did not have to wait, as its calculation was done in a second child process. The result was returned immediately, while the first user was still being run in a different child process, and finally the result. So with the concept of child processes, we have in a way overcome the issue of blocking code, where incoming requests were always welcomed on the main thread. But even with this concept of child processes, I would say as Node.js developers, we should never write such time-consuming code. Imagine hundreds of requests coming in and all of them are for large prime numbers. This will fork out hundreds of child processes, and each child processes will take time to calculate, draining out the resources of the server PC and may even crash the server. Node.js is not the environment for time-consuming codes. Now, for the last and the interesting part of my session, please give me a few seconds. Okay. Normally, how would other applications on your PC access a program written in FoxPro? One of the most obvious ways is via a FoxPro COM object. But can Node.js access FoxPro COM? Let's try. Let's create a new COM project in Visual FoxPro Advanced 32-bit version and name it as FoxFest Server. By the way, any FoxPro developer attempting to create a COM should read this article by Rick Strahl. We will create a new program and define our Ole public class called FoxFest class. It will have an init function with the usual defaults. As this is a COM, we have to make sure that we don't accidentally put any UI, which is taken care by sys2335. Let's define a function hello world, which simply returns a text hello from the VFP world. Save the file with any name. As you know, for a COM object, the important names are the project name and the class name. Our project name is FoxFest Server and the class name is FoxFest class. Build the file as an exe, which will register our class in the Windows registry. Let's check it out by creating an object with our project name dot class name. IntelliSense should show the hello world function, and we see it is working. In the Windows Task Manager, we can see our COM server. If we remove it from the command prompt, it disappears from the Task Manager too. So our VFP COM object is ready in the Windows registry. Our intention is when the user hits a API/test VFP endpoint, it should hit our FoxPro COM server and return hello from VFP world. By the way, instead of the IP address, you can type in localhost if your browser is on the same PC as the Node server. Let's check out npm.js site if any packages are available with the word COM. There are more than 1,000 packages. Let's search for Windows COM. Winax seems interesting. If we check out the GitHub page, we find that the author of this package is Yuri Dursin from Russia. Thank you, Yuri. Let's check you out. We copy the installation command in our terminal and press enter. The installation seems to be a bit different. Why? This is because Winx is written in C++. If you recollect, at the time of Node installation, I had checked the box in Tools for Native Modules. These tools are being put into use now. These tools will compile the Winx C++ code into a Node module. All this is done automatically. We will define a new route file for all the endpoints starting with API. Let's call it approutes2.js. In this new file, let's load Express, initialize our router, expose the router and our test VFP route. Let's load Winx into a variable called Winx. Winx has a method called object which can instantiate a COM server. Let's type in our FoxPro COM server and store it in a variable CON. Unfortunately, this does not give IntelliSense, but we know that our method is hello world. Store the result in a variable, let's say ANS. We will send this answer back to the browser. But before that, we need to remove our COM server from the Windows Task Manager. That's done through winx.release. Now in server.js, we will make Express aware of our new approutes2.js when the API route is hit. So all our routes starting with API will be directed to approutes2.js and all others will be directed to approutes.js. Let's try the endpoint in our browser. Got it. So we were able to call our VFP COM from Node.js thanks to Yuri's Winx. So the API route will hit the /API in our server.js file, followed by test VFP, which will hit the test VFP route in our approutes2.js. Winx will instantiate our FoxPro COM server. We call the hello world method, which returns a text. We close the COM server and finally return the text back to the browser. But we have a minor issue. If you open up Windows Task Manager, we see that our COM server, which was started by Winx, is still open, even though we had given the winx.release command. If we go back to the browser and hit the same route a few times again, we see that the Winx creates new instance of our FoxPro COM server, but it does not terminate it. I have raised this as an issue on Yuri's GitHub page, but till the issue is not resolved, we will use another way to terminate our FoxPro COM server. Fortunately, Node.js has a command called process.kill, which takes in a parameter of process ID to kill the process from the Windows Task Manager. If we look at the Windows Task Manager, we see that each process has a unique process ID. So if somehow we can get hold of this process ID, then we can use Node's process.kill to terminate our FoxPro COM server. So in our FoxPro project, we create another function called getPID. We will make use of Win32 API's getCurrentProcessID method, which will return the process ID. Save and build again. Let's try it in the command window by calling getPID. And it's working. We will go back to our test VFP route, comment out the winx.release, call our FoxPro COM server's getPID method, and use Node's process.kill to terminate it. Save all, run server.js, go back to the browser and hit our test VFP route couple of times. Open up Windows Task Manager, you should now not see a single instance of our FoxPro COM server. Okay, great. Now, it is possible that one or more functions in our FoxPro COM server might take time. Not as bad as our isPrime function, but still it might take maybe 1 or 2 seconds. So to be on the safe side, I would always run my FoxPro COM server in a child process. We have already seen child processes in detail in the last session. Let's create a new JavaScript file called vfp.js. Create a function called testvfp and copy our Winax code from approutes2.js to this new function. We will return the ans to whichever method is calling this function. In our testvfp route, let's load Node's child process module and fork out our vfp.js into a new child process. In the communication method of the parent, on receiving data from the child process, we will send the data back to the browser. In our vfp.js, which will be running in a child process, we'll be having more functions like testvfp. So let's call our testvfp function as function ID equal to 1. Please bear with me, you will quickly see what I'm getting at. In the child listener, I will have another property called function ID in the JavaScript object, which will be passed by the parent. If it is 1, then I will call testvfp function, and the text string it returns will be sent to the parent process. Let's not forget to terminate the child process. In the parent's send method, pass a JavaScript object with function ID equal to 1. Save all and start server. I forgot to do one thing. I have to load the Winax in the child process and remove it from the parent. Save, visit the browser, and we get our same text. No difference, except that our FoxPro COM object is being run in a child process, making sure that if there is any time-consuming code, that is blocking code, in any of our FoxPro COM object functions, then it will affect the current request only. Now let's see how to pass a parameter to our FoxPro COM from the browser. For example, if I want to pass the name Rick to our testvfp function in our FoxPro COM, we have seen how to pass parameters before, so now it should be simple. In our testvfp route, capture the parameter into a name variable by typing :name. Add that as a new property in the send function. The property name could be anything, but for consistency, I will call it name. And for value, we will access the params property of our request object. Next, in our vfp.js file, in the listener, in the child listener, access the name from JSOBJ object and pass it to the testvfp function. Accept that as a parameter in the testvfp function and pass it to our FoxPro COM's hello world function. Modify our FoxPro COM's hello world function to accept the parameter. This time, instead of returning a string, we will return a JSON object. So let's construct one. We will use FoxPro's text merge to create our JSON object. We will prepare 2 keys, one for the name and second for the current date and time. This looks like a JavaScript object. So let's stringify it by enclosing it in brackets to make it a JSON object. We will return the LC variable, which is now a JSON object. The JSON values are actually strings, so I have to put quotes around it. Save and build our FoxPro COM to update the Windows registry. Save the Node project and let's check it out in the browser. Success. So we could pass a parameter from our browser to FoxPro, and FoxPro could return a JSON object back to the browser, all through Node.js. What's next? How about accessing data in FoxPro and returning that back to the browser? VFP Advanced can create and work with tables which are larger than 2 GB. I wanted to create a large table, so let's create one with data from the popular movies database site IMDb. It is free to use. The dataset details are very clearly documented. I created a movies.dbf with field names matching the IMDb documentation. IMDb data is available as a TSV file or a tab separated file which I downloaded, opened up my favorite FoxPro help guide, the Hacker's Guide, and checked out on how to append data from a tab separated file, and done. There we have movies.dbf with more than 7 million records. I have created the necessary indexes. The size of the file on disk is more than 4 GB. By the way, the steps to create the above file is shown on my GitHub page. Browse works. Go bottom browse works. Browse for a condition works. And count works too. The type of the movie, that is, if it is a cinematic movie or it's a TV movie or a TV episode or TV series, etc., is stored in a field called title type. Let's find the count of each title type using our select command. It works and it is fast. Let's create a new function in our COM, name it title count, which will return this title type and its count to the browser. We will store the result into a cursor. We will need to convert this cursor into a JSON object. We can do a scan and do a text merge on each record as we done before, but there is an easier way. Go to VFPX GitHub page and search for NF-JSON. Which is managed by Marco with contributions from Steven and Doug. Thanks a million, guys. Copy the NF-JSON directory to our project directory. Back in our project, by the way, we are dealing with large records, so we have to either set deleted off or create a binary index on the deleted. For this session, I will go with the former. In the init function, I will put a path to our NF-JSON directory. We'll be using only one file from the NF-JSON directory, which is the nf-cursor-to-json.prg. Add that to the project. So NF-JSON is set up. Let's call nf-cursor-to-json with the required parameters, which will convert the current cursor to JSON, which we will store in a variable called LC. Finally, return the LC. Save and build our project. Our FoxPro COM is ready. Back in our Node.js project, create a new function. We can name it anything, but for consistency, let's call it title count. Copy all the code from test VFP function, and instead of the hello world function, we will call our new title count function of the FoxPro COM object. The child listener will get a request with function ID equal to 2 to call our title function. So let's take care of that. So if function ID equal to 2, then the title count function will be called within the child process. Now in the parent process, let's create a new route. We will make a copy of our existing test VFP route. We can rename it to any name we want, but we will stick with title count. The function ID will be 2 and there are no parameters. So let's review. When we get a hit on API/title count, the server.js will pass the request to the approute2.js file. The title count route will fork out our vfp.js into a child process and pass a function ID equal to 2 to it. In the child process, that is our vfp.js, the second if will call the title count method, which will instantiate a new instance of our FoxPro COM and call the COM's title count function. Save all, run the server, and let's check in the browser. Bang! We got the JSON from our FoxPro COM from a 7 million record database of 4 GB size. Isn't this exciting, folks? What else can we do? Let's try returning a report from a FoxPro COM server. If we open our movies table, we will see three fields: title type, primary title, and genres. I have already prepared a FRX with these three fields. Our intention is to generate a report for all movies released in a given year. Nothing fancy here. A picture, a title, a page number, the year for which the report is generated, three page titles, and three fields. Let's check out the report in command prompt. Create a string variable for the year. The year is actually stored in two fields, start year and end year. So this is the report for 1985. So the report is fine. Now to send this report to the browser, we need to convert it to a PDF file. You can use your favorite tool to do this conversion, but for ages I have been using XFRX for all my FoxPro reporting. XFRX can convert a FoxPro report to a PDF too, so let's use that. I have set up XFRX in this project. Let's write a new function to generate the report and send the PDF back to Node.js. This function will get a year as a parameter for which the report is to be generated. Start year and end year in my movies.dbf is a numeric type, so I have to convert the pass parameter to a number. A cursor is prepared with the desired records. Prepare the text year variable. Let's prepare a directory into which this PDF will be placed by FoxPro. And this will be the same directory from which Node.js will pick up the PDF and send it to the browser. I will call this directory FoxFestPDFs in the root of my D drive. Now, what about the file name of the PDF? The file name should be unique for each request. We will handle this in Node. Node, along with the year, will pass this unique file name too. So the full path and the file name of the PDF would be d/FoxFestPDFs/ and the past file name. A few XFRX commands to generate the PDF. This will generate and save our FoxPro report as a PDF into that directory. Return a dummy text to inform Node that the PDF file is ready. Save and build again. Let's test our server in the command prompt. Create the server and call the getFRX with 1985 as the parameter and a dummy file name test.pdf. Let's check out our FoxFestPDFs directory. As you see, the test.pdf is generated. Now, how should the endpoint look like? A new route called getFRX with the year as the parameter. We will quickly repeat all the steps we did with the title count function. Make a copy of the title count route. Change the route name to getFRX. Capture the year into a year variable. Prepare another property called year for the child. Node has to actually pass two parameters to our FoxPro COM. One is the year. Second is the unique file name. Now, there are plenty of packages available on NPM for that, but we will keep it simple. Recollect the middleware function where we incremented the hits variable on every hit to the route. So we can build a file name using the hits variable, as this always will be unique for every hit to our server. So let's prepare this unique file name with PDF as the extension and pass that as the third property to our child process. In our vfp.js, which will be running as a child process, make a copy of the title count function. This will be function id equal to 3. Remove title count and put get frx, which will get the year and the unique file name. Instead of title count, we will call our com's getFrx method, passing the year and the file name. Let's write the third if for function id equal to 3. Get the two properties from the JS obj object and change the function name to getFrx. Once our COM server prepares the PDF, it will send the dummy text which will fire up the parent's listener. This dummy text in ANS variable is of no use to us, but now we know that the PDF is ready. We will prepare the full path of our PDF file and store it in a variable. Instead of manually making this path, we should use Node's inbuilt path module to build the full path. So let's load it into a variable called path. The path module has a join method, and we will build the full path using join. The response object has a send file method, which should be used to send files like PDF back to the browser. I just noticed that I did not change the function id equal to 3. This is what happens during too much of copy paste. So that's corrected. Let's save all our files and run server. Hit our endpoint in the browser. And there you go, a Visual FoxPro report in the browser through Node.js. Let's try with another year 2000 movies. And there's the 2000 movies list. If you open up our FoxFest PDF directory, you will see the two files. If we need to delete these files on successful send to the browser, we can do so in the callback of the send file. The callback will be fired once the file is sent to the client. I hit the same endpoint on my mobile and I get the PDF file successfully. This is thrilling, guys, absolutely thrilling. So we got our data from FoxPro to a web client. We even got our FRX reports to the web client. But I was a bit careful and I ran the FoxPro COM in a child process. What if we get 20 hits simultaneously, that is concurrently? Yes, 20 child node processes would be forked out at the very same time. A child process takes up a bit of resources. So you cannot really have an app where there is very high concurrency. In my white paper, I have mentioned a few possible ways to tackle the situation. I'm still exploring, I'm still learning. In this session, I've made an attempt to explain the asynchronous behavior of JavaScript. Installation of Node.js, that was easy. How a blocking code could create unhappy users and a possible way of mitigating it through child process. We saw how we could access a COM through Node.js thanks to Yuri's Winax module. So our data, whatever it might be, DBF, SQL, MySQL, as well as our favorite FoxPro reports could be sent to any endpoint. My sincere thanks goes to the organizers of this conference, Tamer, Rick, and Doug. Guys, you rock. I also take this opportunity to thank all the speakers, attendees, and sponsors who have made this conference a success. Please fill in the evaluation form to help me improve. Thank you.